Welcome to the deep dive. Today, we're going to cut through some of the noise, maybe some of the anxiety even, around a pretty big topic, the safety of electric vehicles.
Yeah, it's definitely one that gets people talking.
For sure. And specifically, we want to tackle what seems to be the biggest concern for a lot of you that worry about EV battery fires.
The headlines, right?
Exactly. The headlines, maybe stories you've heard. But our mission today, really, is to go straight to the source material. We've gathered, well, quite a bit of research, articles, industry reports.
A good stack.
A good stack, yeah, to give you a genuine shortcut to, being well-informed. We want to move past the sensational stuff and look at the actual engineering, the innovations manufacturers are putting in place to make these cars safe. Really safe.
And what's really fascinating here, and maybe a bit counterintuitive for many listening, is how the, let's say, public perception of EV fire risk, it often doesn't quite match up with the data.
Interesting.
Yeah, the numbers might actually surprise you.
Okay, let's unpack this then. So maybe starting with the big picture, the overall safety landscape. Because our deep dive into the sources, it suggests something that, well, it challenges that common fear, doesn't it?
It really does.
That electric vehicles are actually already showing an inherent safety advantage over traditional internal combustion engine cars, ICE vehicles, specifically when you look at fire risk.
Yeah, that's a bold statement, but the data backs it up.
Yeah.
Sources we looked at, places like Archimede Energy, HT Motory, they consistently point to a lower frequency of fires in EVs compared to gasoline or diesel cars.
Lower frequency. So why? Why is that? Is it just luck?
Hey, definitely not luck. It raises that exact question, why? And the answer the sources highlight is, it's fundamentally about design. It's not an accident.
Right.
The whole architecture of an EV, particularly around the battery and how it stores energy, it's conceived right from the start with fire prevention as a core principle, not an afterthought.
That's a key distinction, isn't it? Moving from just reacting to a fire to proactively preventing it. So what are some of these big advancements manufacturers are making? The things that sort of turn the battery from a perceived weak spot into more of a fortress?
Exactly. Fortress is a good way to put it. There are several key areas. First up, you've got the Advanced Battery Management Systems, the BMS.
The BMS, okay.
Think of it as the battery's brain. Highly intelligent, constantly watching. It's not just passive, it's active. It monitors every single cell, the temperature, the voltage, the current.
Every single one.
Every single one.
Yeah.
And if it spots anything unusual, even a tiny anomaly, it steps in automatically, preventatively.
Wow.
This quick, granular response is just critical for stopping overheating or what's called thermal runaway before a fire can even start. It's genuinely predictive.
So it's thinking ahead, reacting faster than a person ever could. That feels like a totally different approach to safety.
It really is a paradigm shift.
Yeah.
And then there's how they place the intelligent battery placement.
Right, they're usually low down, aren't they, in the floor?
Almost always integrated right into the floor, yeah. Part of the vehicle structure. And that's not just for packaging. It has huge safety benefits.
Like what?
Well, first, it drops the car's center of gravity way down, much lower risk of rollovers, which is a safety win for any car.
Okay, makes sense.
But maybe even more importantly for fire safety, it means the battery pack itself is incredibly well protected structurally. It's nestled inside the strongest part of the car's frame. So in a crash, it's shielded.
So it counters that idea that the battery is somehow exposed or fragile. It's actually part of the car's strength?
Precisely. It helps protect the occupants and protects itself. Then you've got things like pyrotechnic safety switches.
Pyrotechnic sounds dramatic.
Hey, well, they act dramatically fast. In a bad crash, these switches automatically, instantly disconnect the high-voltage battery from everything else in the car. Milliseconds.
Okay.
And that just massively reduces the risk of short circuits, which could otherwise cause fires with damaged wiring. It's rapid isolation.
Got it. Isolating the power source.
Exactly. And development doesn't stop there. We saw mention of innovations, like patents from Stellantis, for example, for new systems for dangerous gas exhaust.
Gas exhaust from battery.
Yeah, you have that rare thermal runaway event, basically a cell overheating uncontrollably. It can produce gases. These new systems are designed to safely vent those gases away, maybe even treat them, to stop them building up or contributing to a fire spreading.
So managing the consequences, even in that worst-case scenario, that's thorough.
It is, very thorough. And finally, just ongoing improvements in evolved cooling materials and techniques, better battery chemistry, sure, but also much smarter, dedicated cooling systems, liquid cooling, advanced thermal management.
Keeping things chill.
Basically, yeah.
Yeah.
Actively managing the battery's temperature all the time, keeping in that safe operating zone, even during fast charging or hard driving.
It's actually amazing when you list it all out, how all these things from the cell chemistry up to the car structure create this layered safety net. It makes EVs seem incredibly resilient, maybe way more than the scary headlines suggest.
It's a great summary of the overall picture.
But here's where our deep dive gets, well, really interesting, I think, because it shows how specific components, things you might not even think about, are also getting serious safety upgrades. Let's talk about the DC-DC converter.
Ah, yes, the unsung hero.
Oh,
Or sometimes, perhaps unfairly, pointed to as a potential issue.
right. So what exactly is it, and why is it so critical?
Okay, so the DC-DC converter,
Hmm.
its main job is crucial. It takes the really high voltage direct current from the main battery, we're talking hundreds of volts, and it steps it down, converts it to a much lower voltage DC, usually 12 volts.
Like a traditional car battery voltage.
Exactly like that. And that 12-volt power is what runs pretty much everything else in the car that isn't the main motor. Your lights, the wipers, the big infotainment screen, all the little computers, power windows, AC,
Basically everything you interact with besides the accelerator?
pretty much. Without that converter, none of that stuff works.
Yeah.
So, yeah, it's essential.
Okay, essential, got it. But you hinted it could be a potential issue. What are some of the challenges or risks our sources mentioned, maybe historically, with this component?
Well, like any electrical component handling power, there were areas needing focus. One is simply overheating. If
Yeah.
it's overloaded, maybe drawing too much power for all those systems. Or if there's an internal fault, like bad insulation, it could get too hot.
Okay, heat is always a concern with electronics.
Always. Another potential issue was vulnerable placement. In some older designs, maybe its location made it a bit susceptible to damage in a crash, or even water getting in, which is obviously bad for electronics.
Right, impacts or water, yeah.
And finally, maybe material selection. In the early days, perhaps the materials used for the casing or inside weren't always as fire retardant as they could have been. If a fault did occur, it could potentially be a source of ignition.
So, real engineering points to address. But as you said, the key thing is manufacturers are addressing these. They're not ignoring the converters.
Oh, absolutely not. The progress here is significant. For starters, constant monitoring is now standard. These converters have sensors, often redundant sensors, constantly checking for high temperatures or any weird behavior.
And this information goes where?
It feeds right back to the car's main computer and, importantly, the battery management system we talked about earlier. The BMS can then react, maybe reduce power, flag an issue long before it becomes serious. Again, proactive.
So the car knows if its own converter is getting stressed? That's smart.
Very smart. And linked to that, we're seeing widespread use of dedicated cooling systems, often specific liquid cooling loops, just for the converter.
It's on a little radiator.
Sort of, yeah. It means it can handle high loads without overheating. Targeted thermal management, keeping it well within safe limits.
Okay, so better monitoring, better cooling.
Right.
What about containment if something still goes wrong somehow?
Good question. That's where fireproof materials and compartmentalization come in. Converters today are built with inherently fire-resistant materials, and often they're physically installed in their own isolated fire-retardant box or compartment within the vehicle.
Ah, like containing it.
Exactly. The idea is, if the worst happens and a fire starts in the converter, it stays in the converter. It's contained, limiting spread to other parts of the car or the cabin, another safety layer.
That makes a lot of sense.
And then there's the broader system response, automatic disconnection and emergency procedures. If there's a serious fault, or definitely if a fire is detected, the safety systems can automatically cut power to the converter and even disconnect the main high-voltage battery entirely.
Like those pyrotechnic switches we mentioned earlier.
Similar principle, yeah, isolating the energy source.
Yeah.
This not only limits damage inside the car, but it's also a huge deal for first responders. It makes the vehicle much safer for firefighters or rescue crews to approach and work on. Knowing the high voltage is shut down is critical for them. The procedures help them make the vehicle safe quickly.
Right. Safety beyond just the driver. That's important too.
Hugely important. And kind of tying all this together is the influence of updated regulations and guidelines. Manufacturers don't just do this out of goodwill. They have to meet strict international standards, like from the CEI, and national rules, like from fire departments.
Setting a high bar for everyone.
Exactly. These regulations demand rigorous testing for all components, including converters, and define specific emergency procedures. It ensures a consistently high safety level across the industry.
It really paints a picture of a very thorough, multi-layered approach. From the car's basic design down to these specific, crucial components like the DC-DC converter, it feels like a constant evolution of safety thinking.
That's precisely what it is.
So let's maybe circle back then, try to pull it all together. The big takeaway from this deep dive seems clear. Electric vehicles, they aren't the inherent fire risks some headlines might suggest. In fact, they're arguably becoming safer than traditional cars in that respect.
Yeah, thanks to all these things working together, the smart electronic management, the better materials, the physical design, the safety architectures,
It all adds up.
it really does.
Yeah.
And if we connect this to the bigger picture, it's obvious that for these key components like the DC converter, this combination, the constant monitoring, the dedicated cooling, using fireproof materials, putting them in safe compartments, having those automatic disconnection systems, that's the most effective way to slash the fire risk and boost overall EV safety.
Right.
The engineering and the data, they really are changing the game for vehicle safety.
So maybe the final thought for you, the listener. What does all this mean? Perhaps it's about seeing these cars not just as, a different way to get around, but as proof of relentless innovation in safety engineering. Innovation that's focused on preventing problems, protecting people, maybe in ways that could even inspire how we design other powerful electronics we use every day. Something to think about.
Definitely something to think about.
Well, thank you so much for joining us on this deep dive today. We really hope you feel better informed, maybe less anxious, and perhaps even a bit impressed by the safety engineering going into modern EVs.
Hope so.
And hey, if you found this deep dive valuable, we'd really appreciate it if you hit that like button. It helps others find the information too.
Yeah, please do.
And to make sure you don't miss our future explorations into, well, all sorts of fascinating topics, be sure to subscribe to the Deep Dive channel.
We'd love to have you back.
We'll be back soon with more insights. Thanks for listening.